Hello and welcome to yet another video of Cornerstones of Math. Today I will solve the following problem. Prove that the system of equations cube root of x plus cube root of y equals 2 and x to the 4th power plus y to the 4th power equals 2 to the 12th power has exactly two pairs of real roots x, y and find those roots. Now finding the roots is really easy. We can just straight up guess the roots because the numbers given on the right hand side are very special. Concerning the cube roots, notice that cube root of 8 is 2, and since 8 is 2 cubed, if you raise it to the 4th power, you obtain 2 to the power of 12. This means that x, y equals 8, 0 and 0, 8 are roots of the given system of equations. The more challenging part of this problem is, how can we guarantee that these two are all possible pairs of real roots? Now, some of you might have a knowledge on what do the graphs of these equations look like, and therefore easily deduce that 8, 0 and 0, 8 are indeed only possible pairs of real roots. The problem with this visualization method is that many of you may have never rigorously proved why the graphs look like these, but just accepted them empirically by plotting them with the graphing calculator like in here, without a concrete proof. For the complete and rigorous proof, we need to prove several characteristics of these graphs using calculus. But I'm going to use calculus in another way in this video, which I will show you in the end. The proof that 8, 0 and 0, 8 are only possible real roots can be done without using calculus, so I'm going to explain this less advanced method first. We need to divide the cases depending on signs of x and y. Remember, cube root of a can be defined as a real number even if a is negative, so we need to take a look at those cases too. If x and y are both negative, then cube root of x is negative and cube root of y is negative. Hence, cube root of x plus cube root of y is also negative, making it impossible to become 2. If x is greater than or equal to 0 and y is less than 0, then cube root of y is less than 0. Hence, cube root of x, which is 2 minus cube root of y, is greater than 2, making x is greater than 2 cubed, hence greater than 8. But as for the 4th powers, this gives x to the 4th power plus y to the 4th power is greater than 2 cubed to the 4th power plus 0, which is 2 to the 12th power, which means that equation 2 cannot be satisfied, hence this is another invalid case. The same logic applies if x is negative and y is non-negative. Lastly, both x and y are greater than or equal to 0. We need to do some algebra here, and I prefer simpler notation when doing algebra, so let us make a substitution cube root of x as capital letter X and cube root of y as capital letter Y. Then we have the condition capital letter X is greater than 0 and capital letter Y is greater than 0. And the equations are capital letter X plus capital letter Y equals 2, and using small x equals capital letter X cubed and small y equals capital letter Y cubed, the second equation becomes capital X to the 12th power plus capital Y to the 12th power equals 2 to the 12th power. Here, small x, small y being 8, 0 or 0, 8 is equivalent to capital X, capital Y equals 2, 0 or 0, 2, and I will prove that this system has no real roots other than these two. Let's assume that there exists a root in which both capital X and capital Y are positive. If one of them is 0, we just obtain one of these roots, so it is reasonable to assume that if other root exists, it must be from the region where capital X and capital Y are both positive. then this root will satisfy both equations. Notice that if we raise equation 1 to the 12th power and subtract equation 2 from that, it gives capital X plus capital Y to the 12th power minus capital X to the 12th power plus capital Y to the 12th power is equal to 0. We can expand the first term using the binomial theorem. Here, x to the 12th power and y to the 12th power terms get cancelled because of these negative terms in the end. So we only have 12 choose 1 capital X to the 11th power times y plus 12 choose 2 capital X to the 10th power capital Y squared plus up to 12 choose 11 capital X times capital Y to the 11th power. And this equals 0. The left-hand side is positive and the right-hand side is 0. Hence contradiction. This means that this hypothetical root where capital X and capital Y are positive cannot exist, meaning that 2, 0 and 0, 2 as capital X, capital Y are only real roots. And this concludes the proof. Next, I will show you the calculus method, which is indeed a famous method to prove the uniqueness of the root of an equation. But let us use calculus in a simpler way compared to what I have described in the early part of the video. We'll use the substituted version of the equations containing capital X and capital Y. We want to prove that this system has exactly two pairs of real roots. The obvious roots capital X, capital Y equals 2, 0 or 0, 2. We can easily eliminate capital Y from equation 1, which equals 2 minus capital X. Then equation 2 becomes x to the 12th power plus 2 minus x to the 12th power equals 2 to the 12th power. So let function f capital X be capital X to 12th power and 2 minus x to the 12th power, and show that the function becomes 2 to the 12th power only if x equals 0 or 2. We take the derivative, which gives 12 times x to the 11th power minus 12 times 2 minus x to the 11th power, hence 12 times x to the power of 11 minus 2 minus x to the power of 11. It is not difficult to find that the derivative becomes 0 at capital X equals 1, and that it is continuously negative on the left and continuously positive on the right. So the function decreases and have the minimum value 2 and then increases. So because the graph of fx looks like this, there has to be only two values of capital X, which give 2 to the power of 12 as a value of the function, and those values are 0 and 2, corresponding to roots capital X, capital Y equals 2, 0 or 0, 2, hence confirming small x, small y equals 8, 0 and 0, 8 as only real roots. And that's all for today's video. Thank you all for watching. Please hit the like button if you enjoyed this video, and I will see you in another video.